Okay, in that last video, I had indicated that you should start the assignment. For some people, you're able to work through it. Others need some more worked out examples to kind of get the gist of it. So what I've given here are 3 examples. We're going to go through those really quick. So you can see me doing a few, then you can maybe after you see me doing some, you can get the gist of it and try it yourself. So our first example right here, again, I've got 2 parallel lines, a transversal, and some of these are going to go really quick. So for instance, angle 1 here doesn't have anything to do with these being parallel. These 2 angles are vertically opposite. They're across from one another in the x. And we talk about that all the time with my grade 10s. If they're across from one another in an x, then they're the same, vertically opposite. So this one is 112 degrees. So I like to put that right in my diagram, makes it easier. So the next thing I see that's fairly easy, fairly obvious, is this is top left, and angle 2 is top left. Okay, so top left angles, they're corresponding, so they have to be the same. So angle 2 is 112 degrees by the corresponding. So I have one more left to go. That's angle 3. Again, a couple of ways you can figure that one out. What I would look at is the fact that you've got a nice straight line right here at 2 and 3. Break that straight line up into 2 halves, right? So you know that there's 180 degrees in a straight line. So 180 degrees minus the 112 that's already right here would leave you with 68 degrees. And if we were naming theorems here, right, angle 3 we just said was the straight line, right, or supplementary angle theorem, so we can abbreviate it that way, SAT. Angle 2 we used corresponding. Okay, and when we found angle 1 we did vertically opposite, so vertically opposite angle theorem, so we can abbreviate it that way. And I have a PDF notes for you that have these theorems as well, so you should download and print that off. And those are, again, ones from previous years. Next. So this one's a little hard. They've twisted it compared to what we're normally used to, okay? And they've cut the lines off. Anytime I see a cut off line, I like to just extend it myself. And then it looks more like what we're used to. Now it looks like normal. Now I can't rotate this one because it's part of a much bigger diagram, but you can on your paper. If you rotated it around, you would see that this is the top left, and so is angle 4. They're in corresponding positions, so they have to be the same. So angle 4 is going to be 53 degrees. Let's put that in there. And we use corresponding. Now angle 5, you'll notice once again, nice straight line, cut in 2 halves by angle 4 and angle 5, so that total has to be 180 degrees. So 180 minus 53 leaves you with 127 degrees. We use the straight line or supplementary angle theorem there, and there we go. Moving down to C, this time it does have the normal orientation that we're used to. Again, I like to continue these out. This time I have a very nice C rule going on right here. Co-interior angles. So the C rule tells you that the 2 co-interior angles have to total 180 degrees. So 180 minus 68 leaves me with 112 degrees. And use the co-interior. On to D. This one, again, I like to extend these out so I can very easy to recognize your transversal and parallel lines. So now, a little more difficult. There's nothing wrong in this case if you wanted to use more than one rule or figure out more than one spot in order to figure out what angle 7 was. For instance, I could go directly to the alternate exterior, or sorry, the co-interior right here, gain C rule, and say that has to total 180, so this 70 degrees in here. And then I would say this angle and this angle are together on a straight line, and so that has to be a total of 180 degrees, so this is 110 degrees. So we used two different spots, and I solved an angle that they didn't ask for. There's nothing wrong with that. It's perfectly legitimate to solve for an angle that's not even asked for first, and then get the one that you were looking for. The more direct route to getting this would have been the Z rule. Alternate interior. So 110 and angle 7 are alternate on alternate sides of the transversal, interior on the inside of the parallel line, so they have to be the same. So angle 7 is 110 degrees, and we used alternate interior. One more. So again, I'm going to extend lines as they didn't here. Extend that one out, extend that out, extend that out. All right. Again, this will be easier for you because you can rotate your paper around. And once again, you're going to solve in whatever order you want. And I've got basically two diagrams here. I've got one like this, and then I've got another one up here where I've got two parallel lines of transversal. So the easy one to solve is this one down here. As I said in the previous video, if I've got the setup like this, two parallel lines of transversal, all I need is one angle to solve all of the rest. So for instance, angle 3 is vertically opposite from the 72 degrees, right, across from the x. So it has to be exactly the same. So 72 degrees here. Angle 4, combined with angle 3, make a nice straight line. Supplementary angle theorem, so I go 180 minus 72, that leaves me with 108. So there's 108 degrees. And then we use the straight line or the supplementary angle theorem for that one. Now angle 2 right here, a couple different theorems I could use. I would probably recognize top right and top right are corresponding first. Tell you that those two have to be the same. So angle 2 is 72 degrees by corresponding. Some people may have seen this one, alternate interior, or the Z rule. So let's mark that in there, 72 degrees. Now, let's look at this top one up here. Say, how am I going to solve this? These two aren't even parallel. Well, we do have one angle right here. Looking at just that top portion, we're going to look at the C rule. And this is where rotating your paper around so that this is orientated straight up for you makes it easier. You can't do that here on the board with rotating everything. So these two angles added together have to give you a total of 180. So 180 minus 55 leaves you 125. Right, and we use the co-interior. So there are some worked out examples to help you get through some of the assignment.